So we're going to take a quick look at problems 5 and 6 from Math Madness, round number 4. A regular pyramid has a square base with sides of length 1, and 4 triangular faces are isosceles triangles whose equal sides have a length of 2, just like the drawing. The total surface area of the pyramid, including the base, can be written in simplest form as m plus the square root of n. Okay, well, let's start with the easiest thing. We know that the base has an area of 1 because it's a 1 by 1 square. So I'm going to put that over here just so I don't lose it, right? But now the harder thing is trying to figure out this area of the the face of the pyramid. So I'm going to go ahead and draw this pyramid face. So we know that this length is 1, and we know that this length is 2, and if I drop this altitude down, we know that since it's an isosceles triangle, this part right here has a length of 1/2. This length here has a length of 1/2 as well. Oh, this is just a Pythagorean Theorem problem. A squared plus b squared equals c squared. Now, I can find the area of 1/2 of this triangle and then multiply it by 2, right? Okay. So the area of a triangle, or sorry, not the area, but this length right here, this altitude, I'm going to go ahead and draw it, forms a triangle that looks like this. 1, 2, oh. That's not 1, that's 1/2. So the Pythagorean theorem says a squared plus b squared is equal to c squared, where c has to be the longest side length. So we have 1/2 squared plus b squared is equal to 2 squared. Well, 2 squared is 4. 1/2 squared is 1/4. So we have b squared is equal to, and we have 1/4, so subtract 1/4 from both sides, and we will have b squared is equal to, well, that's 16/4, so that's 15/4. All right, so then, what's the opposite of squaring something? Taking the square root. So we'll take the square root of all of it, and so we get this length here is going to be equal to the square root of 15 over 2, because the square root of 4 is 2. All right, so what is the area of this triangle? Well, the area of a triangle is going to be written in the form area is equal to 1/2 base times height. But wait a second, I don't just want to know the area of this triangle, I want to find the area of this triangle and this triangle, both of them together. So normally I'd say 1/2, but really I don't have to say 1/2 because I'm going to just double it anyways. So I know the area of the triangle is going to be base times the height. And the base is 1/2. The height is square root of 15 over 2. And so I will get the area of one face is going to be square root of 15 over 2 over 4. So that's one of them, right? So one of these right here, the area of this is 15 square root of 15 over 4. And I have 4 of them, right? 1, 2, this one here, 3, this one here, 4. So square root of 15 over 4 times 4 is going to be, well, that just cancels out. It's the square root of 15. So n has to be the square root of 15. Or sorry, 15, because it's just 1, right? So 1 plus 15 is 16. All right. So now let's take a look at the next problem, number 6. I'm going to clear this so I have a little more room. So number 6 says, we're going to let n be a 2-digit number in which neither digit is 0. Okay, that makes life easier. And m is going to be the number formed by reversing it. So we know that n is going to be equal to, it's a 2-digit number, right? So we have in the tens place, a 10 times a plus b. In other words, we have our digit a and our digit b, but if I just do ab, that's a times b, that doesn't help. And this is the tens place, so we're writing it in expanded form. And m occurs when the digits are reversed, so that'd be 10 times b plus a. All right, so then we know that n is greater than m. And we want to know the smallest value of n such that n squared minus m squared is divisible by 4. All right, so, well, I know that n is simply 10a plus b. And we're going to square that. Why? Because it says squared. And we're going to subtract the m value. And our m value is 10b plus a. And again, it says squared. So now we have to square this. Now, if I square something, it's just multiplying it by itself. So we are going to go ahead and multiply it by itself. So to do that, I'm going to use some different colors. How about white? How about use that a bit? So we have 10a plus b times 10a plus b. So that's going to give me 10a times 10a, which is 100a squared. 10a times b is going to be 10ab. b times 10a is going to be, again, 10ab. b times b is b squared. And so kind of combine the similar terms, and that's going to give me 100a squared plus 20ab plus b squared. Well, we have to deal with the second part as well. So let's go ahead and do it. We're going to have 10b plus a times 10b plus a. And using the same process of rainbows and smiley faces, we are going to get 100b squared plus 20ab plus a squared. All right, now I didn't show it step by step. That's the way it goes. Well, we are going to subtract these two. Trinomials. So it's my least favorite color. So we have 100a squared plus 20ab plus b squared, and then we are going to subtract it from this whole term, 100b squared plus 20ab plus a squared. Well, what is 100a squared? Now we have to combine the similar terms, and the only thing that, and we can only combine things that have identical variables and exponents. So a squareds are the same as a squareds. So what is 100a squared minus a squared? Well, that's 99, maybe. Maybe, please. So that's 99a squared. What is 20ab minus 20ab? Well, it's just 0. Okay. So what is b squared minus 100b squared? Well, that's minus 99. I'm having troubles with my pen. I'm sorry about that. 99b squared. All right, so great. Well, 99a squared minus 99b squared, what number is in both of these? 99. So I can further simplify this into factored form because we really have 99 times a squared minus b squared. How did I do this? Well, simple. 99 times a squared is equal to 99a squared. 99 times b squared is 99b squared. All right, so how does that help me? Well, let's go back to the question. We need this thing to be divisible by 4, which means whatever is inside this term right here has to be divisible by 4 because 99 is not divisible by 4. And we want the smallest possible number to be that is divisible by 4. So what numbers can we plug in for a and b that will get us something that is divisible by 4? So, so a has to be larger than b. So we know the smallest we can start with is 2 and 1. So 2 squared is 3. 1 squared is 1. 4 minus 1 is 3. 3 is not divisible by 4, doesn't work. So let's plug in 3. 3 squared is 9, minus my 1, because 1 times 1 is 1, that's 8. Oh. So if a is equal, oh, come on. If a is equal to 3 and b is equal to 1, then I will get something that's divisible by 4, because that would mean that we'd have 99 times 8, and 8 is divisible by 4. So what exactly are we being asked? We're being asked, what is the 2-digit number where n, okay, so the 2-digit number, n, because n has to be bigger than m, it has to be 31.